Thanks everyone for joining us today. We've got an exciting webinar to present to you on the topic of accelerating OpenAPI design and development with advanced mocking. And one of the tools we're going to be showing off today is ServiceV Pro, along with some Swagger and Swagger Hub. So before we get started, just want to introduce our wonderful panel of presenters today. First off is Harsha Preddy. He's the product marketing manager here at SmartBear. He's got some really cool slides that will help kind of walk us through the concepts of mocking and how you can take that to the next level. And then we've got Mike Hawley, who's our engineer, and he's going to be diving into the tool and kind of show us really how everything works. So that's really exciting. Just a couple of quick notes before we dive into the agenda. The webinar is being recorded, so we'll be sending that out via email later this week, so stay tuned for that. And don't hesitate to ask any questions. You'll see the chat box at the bottom of the Zoom webinar here. So just feel free to chime in with any comments or questions, and we'll do our best to answer those when appropriate. So without further ado, I'll kick it over to Harsh to walk us through the agenda.
Thanks, PJ. Hi, everybody. My name is Harsha Preddy. As PJ introduced me, I'm the product marketing manager for APIs here. And today we have a very interesting topic for you. It is around OpenAPIs. It's around mocking and service virtualization. So we're going to talk about OpenAPI definitions. We're going to talk about mocking, how you can take OpenAPI definitions and you can create mocks out of them for different purposes. We will take a look at service virtualization and how it can be beneficial to you when you're designing and developing APIs. We will look at the value that service virtualization brings to you and your team. And throughout the presentation, we're going to be doing a demo. We'll stop a couple of times, and then Mike is going to show you the tools that we will be using. That includes the Swagger Hub tool that we have, and also ServiceV Pro. Okay. So before we begin, I think it's good. It makes good sense to talk about what is OpenAPI specification. So OpenAPI specification is nothing but it's a standard contract between different RESTful APIs. So it is something very similar to what we had for SOAP. SOAP had a WSDL contract. So those APIs evolved into RESTful APIs, and there was a thought that we should think about RESTful APIs in more standard way. We should have a single source of truth for RESTful APIs that we can take across the lifecycle of the API, and that's where OpenAPI specification comes into play. So it acts as a single source of truth, and you can take that specification and you can do whatever you want with it. You can use it to generate code. You can use it to generate tests. You can also take it to generate monitoring scripts. This specification is very much independent of language, any framework, or any technology. It is based on JSON and YAML. And well, it supports both. You can take the specification and you can do coding from the specification. As I said before, you can generate code skeletons and stubs from the specification, or you can also do it the other way around. If you already have APIs, you have already written methods, then there is a way for you to annotate those methods in code and then generate open API specification. It's a pretty open framework. And the good thing about it is that there are so many people involved around the specification. There are big companies involved with the specification and its development. There is a huge community that works around the OpenAPI specification. There's a bunch of tools available, open source tools. That a lot of them are supported by SmartBear, which you could go online and use to do and get started with your OpenAPI strategy. So you can see on the right, it's an example of a specification. So it's all in English. It's not complicated. It defines pretty much everything around what the parameters in the API are going to be, what the description is going to be, what different schemas you're going to be using, the type of parameters, the response code, and everything. So it's a very standard way of defining an API and taking it across your whole API development lifecycle. So let's talk about mocking. And well, when you're doing APIs, it's important for you to take those APIs and make them live in certain sense. Like you want to see those APIs in a way. So you try to emulate them. So you do it through a couple of ways, that is mocking and through sandboxing. So mocks are static emulation of APIs. So you may not have an actual API yet, but you might want to mock up something for your own purposes. So this is mocking. So you do that with generally on a programming language. You write code, you use some tools to do it. And you also have sandboxing, which is essentially a pre-provisioned instance of an API endpoint, which is done by a third party. For example, if you're working with a bank, that bank might give you a sandbox that you could use for your purposes of development and testing. As you can see that these are controlled by third parties, and these are only valid for very specific use cases. So there are many tools available for mocking, which includes so we have SoapUI open source. You can do mocking on SoapUI open source. There are other tools, including VirtServer and a bunch of other offerings are available in the market where you can do mocking. And sandboxing is a service. There are a couple of tools which are available, like WireMox and GetSandbox. These are online SaaS-based tools. And if you're working as an API developer or a tester with third-party APIs, you can ask your team to build a sandbox for you. Okay, moving on. So, well, talked about APIs. We talked about API specification. We looked at mocks and what sandboxes are. But then there are a lot of issues that you would face if you're working with mocks and sandboxes. Well, number one, these are very hard to create. They require a lot of manual configuration. You have to actually do a lot of scripting to create a mock from an API. So often what's going to happen is that you're going to ask your developer who has developed the API to create these mocks for you. So you depend on other teams to create these mocks and sandboxes. Unless you're a developer of the API yourself, it'll be very hard for you to come up with these mocks. Mostly these mocks and sandboxes are owned by other teams and third parties. So you may require certain use cases from those APIs, but it will be very hard for you to convey that information to the third party or the other team and ask them to change it according to your specifications. Because of course, those people have their own timelines and deadlines. They may or may not comply with your request. Mocks and sandboxes are also very static. They are limited to very few scenarios. Even if you're doing mocking yourself, you can do it for one particular scenario. That means, for example, you can do it for a login. But then if you want to take that existing scenario and change it to something else, it requires a lot of effort. So it's very hard for you to create multiple responses on these mocks and sandboxes. And these are stateless. So you cannot actually attach a state to the mock. And by state, I mean credential information, cookie information that you want to take and pass throughout different responses of your API mocks. So it's very hard to do it. So here's an example. Like, for example, if you're doing mock from an OpenAPI specification, the response would look something like this in the box, in the blue box at the bottom. And you will have different values in this responses, but unless you have a software or a tool that can change these values for different parameters, it'll be very hard for you to do it yourself. So for example, the name here is Acme Corporation, but you may want to test this API response for other things, like you may want to test it for another company name, which could be in some other language, right? It could be in Mandarin or it could be in Spanish. But unless you have a tool that enables you to change that name quickly, doing so yourself is going to take you a lot of time. And it'll be very hard for you to do it yourself, because you can do it for a couple of 2 or 3 names or 5 names, maybe 10 names. But what happens if you have to test that API for maybe 1,000 different scenarios? Then you run out of time to do it. So yeah, you can't. So mocks and sandboxes, you cannot cover multiple scenarios. It's very hard for you to route between your mocked API and the actual API. So you will have to change the URL in your code or in your testing setup. The URL will have to be changed to point to one time to a mock and then later on to an actual API. So it's very hard for you to do because it has to be done manually. And the mocks and sandboxes do not provide you an attached state. You cannot actually take a set of parameters and pass them across different responses. So these are some of the problems that you face with mocking and sandboxing. All right, so we talked about OpenAPI specification, we talked about mocking, and this is typically how you would be doing work if you are actually taking the specification, or if you're working on an API and you are actually doing development, testing, and production. So you have an API on the left, that is the OpenAPI specification logo, and then you take it and you, before it can be made available to your consumers, which includes your developers or customers or users, you have to do something. You have to develop it. All right, either you have to develop this API first, you have to have that API available after you have coded it. And then once that is done, you make it available to your testers or third-party developers who want to use it. And then you will also have to test it if you want to ensure that those APIs perform really well to some extent. So unless you do that testing, those APIs are not available to your customers and end users. And only when you make it available in production, you can give it to your end users. Like if you're developing an API for an app, and only once that API is available in production, it's ready to be used, you can integrate it with your app, and then that app could be made available to your end users. So in this case, if you want to do some kind of prototyping of your application or your APIs, it's very hard to do because you have to put in a lot of effort before you can actually make any version of this API available to your end users, right? Because the problem is that mocks are not useful here because they are so static. They cover just 2 or 3 scenarios. As we talked about, they don't have a state. So you cannot do much with it. So you have to go through with this whole life cycle, or at least a few stages of it before you have an actual API available to you. So we will try to solve this problem with service virtualization. But before we do that, I just want to make sure that we have our concepts on service virtualization clear. So what is service virtualization? Service virtualization is a way of accurately simulating the behavior of a component that is not available or it's difficult to access during the software development and beyond. So what you do is that if in case you have any component, like for example, a device which is not available, a database that is not available, already expensive to set up, or it is owned by a third party or an API or a network, what you can do is that you can virtualize these artifacts and then you can use it for your purposes of testing, development, and prototyping. So this is what virtualization looks like. And today we're going to be talking primarily around API virtualization. So an API which is not available, or if it is in the initial stages of design and development, you can just create a very realistic simulation of it using service virtualization. So I think at this point, it makes sense for us to take a pause, and I'll let Mike show you an OpenAPI specification and a way in which how you can create mock before we go on to talk about service virtualization and solve the problem that we talked about in the last slide.
All right. Thank you very much, Harsh. Welcome, everyone. My name is Michael Hawley. I'm a sales engineer over here at SmartBear. And yeah, we're going to be taking a look at a Swagger specification, OpenAPI spec here. See some of the limitations of the mocking. I'll show that off, and then we'll get into some of the benefits of virtualizing and using a tool like ServiceV. So here we have in front of us a Swagger OpenAPI API design. In this case, it's a library here. We've got the actual design here over on the left, and over on the right, because we're using a tool that SmartBear developed called Swagger Hub, we're able to see the documentation and interact with it in a couple of different ways. Right. So beyond that, Swagger Hub is also a collaboration tool, so we're able to not only design these APIs and create this interactive and live documentation that gets updated in real time, but we're also able to mock these APIs. We're able to create some of these read-write permissions and organizations that one might encounter in your development cycle here. All right. So what I'm going to be showing off is the ability to create a mock within Swagger Hub. It's really quite simple. We've got an integration here. We're going to try it out. We're going to look for a specific book. Here we go. RESTful web APIs, services for the changing world. And then we're going to execute this. What this does, it helps us create a curl command and a URL. So in this case, I'm just going to be using this curl command really quickly. Oops. There we go. And be able to show off how we can get a response from the command line here. So we're able to interact with this. The issue with this method here is that no matter what kind of title that we input as a parameter, no matter what kind of author or ID for this book, we're always getting back the same response. There's no context. There's no different ways we can dispatch different responses, and there's no, it's completely stateless. So while this is good for some initial prototyping and sort of seeing how we can, at a very high level, how we can interact with this API, it's not as robust as we might need for more prototyping as we get later on into other stages of the development lifecycle, especially testing.
So Mike, correct me if I'm wrong, but I think the values that this mock response gives you is the example, the sample values that you set up in the design, in the Swagger specification. And if you want to change these values, then if you'll have to change the sample values in the specification.
Yep, that's
Okay.
exactly right.
Okay.
There's a lot of work involved in changing these.
Okay.
Absolutely. All right. So let's go back to our slides here. So we've talked a little bit about mocking these API calls, the sort of static implementation for these scenarios here. We make that request and we get back a single static response. It's completely stateless, so no matter what parameters we put in, whether or not we want to get back a different response, we'll always get back the same one. It's completely manual, so like Hirsch said, it requires a lot of work on our end to create different responses. We would have to change the example of values here in this case, and it's not reusable at all.
Absolutely.
Yeah.
Absolutely. So yeah, so this slide kind of puts the mocking and virtualization in front of you to compare. So again, mocking, as Mike mentioned and showed it to you as well, that it's pretty static, and you can do mocking using any tool. It's also called stubbing in a lot of cases, but then you can do it for one response or two responses, maybe 10, 20 if you're really putting a lot of time into it, right? And whereas virtualization, because it's a tool that enables you to create these very sophisticated advanced mocks, or which are very realistic, the tool provides you, like we will show you ServiceV in just a moment, which it provides you the ability to actually take one single response of your API or one particular endpoint and then quickly clone it or link each and every response parameter with a column of a data source. So, and the data source could be a database, it could be a Excel file, and that could contain hundreds and thousands of rows. And in a sequence, your API, your mocked API, your virtualized API will respond one by one values from that data source. So it enables you to do much more in a very short period of time. And again, mocking is very stateless. Like there is no way in what Mike showed you could have added a state or login credential across multiple requests. So it's fine if you want to just check one API endpoint and see, hey, what's going on with this API endpoint, which kind of response I'm going to get, what the structure looks like, whether it's working or not, mocks are fine. But then if you want to do a scenario like, hey, I want to log in, I want to do a transaction and log out. These are 3 or 4 API calls. And you will have to transmit a lot of cookie information across these 4 API calls. You have to transmit a lot of credential information across all these API calls. So with mocking, it is going to be really, really hard for you to configure that unless you know coding scripting. But with virtualization, the tools that we will show you, it provides you the ability to kind of set these parameters up front and then pass them as cookies, as headers across all the requests. So, and no need to say this, but again, mocking is primarily 100% manual configuration. You have to do a lot of work. You have to configure it all the time. But virtualization, no configuration required. You set it up, you save the project. You can share it with your team over Git, or if you want to share the virtual APIs with teams over network or over cloud, you deploy it on our cloud component, and it is available to your teams across the world. So. And then reuse. So as I said, it's very easy for you to take what you have created in virtualization and then copy it and multiply those scenarios a number of times to do more with your virtualization. But with mocking, any kind of reuse would involve you to take the scripts and copy them all over again and modify them all over again. A lot of work. And imagine the amount of work that you have to put in when you have to change one scenario. Then you have to go in and change the code for each and every place where you have copied that script for your mocks. So yeah, that is the value that virtualizing your API adds to your SDLC. So let's talk about ServiceV Pro, the tool that we're going to be showing you shortly. So ServiceV Pro, it's a service virtualization solution. It enables you to quickly create virtual environment for APIs and also databases. So you can record and replay APIs, modify them, make them really advanced, almost realistic. And you can also do that same thing for your database transactions, your JDBC transactions. You can easily record your API transactions. You can modify them and use them for your whatever purpose, testing, development, prototyping, whatnot. And recording is pretty easy. We'll show you that when we do the demo. And you can make these virtual services very realistic by linking them to data. We talked about it, linking your response parameter, each and every parameter to a column in the database. It's very easy. It's just a few clicks. And once you have done that, your response of your API will pick values from each and every row of your database and respond that in a sequence or a logic defined by you. And if at some point if you're testing, prototyping, or developing, and you're like, okay, at this time, I want to actually hit the real API instead of the virtual API, you just have to click a button, and all your requests will start getting routed to the actual API instead of the virtual API. And then you can take these APIs, which you have created, the work that you have done, and then you can share these APIs with anybody. So if you are an API developer or a designer, and your consumers are your customers, and they want to see what work you have done, they want to see a realistic simulation of your API, you can take your Swagger specification, put it on ServiceV, create those virtualized APIs which are really advanced, and then share them over the network with your customers. So overall, this tool, service virtualization, gives you a lot of control. So you don't have to depend on a third-party company. You don't have to call somebody to make those modifications to that sandboxes. So you get all this control. You save a lot of time. So you can do prototyping early. You don't have to do all that configuration and manual coding. So you are delivering products faster to the market. And you save a lot of money because all the time that you saved, and your products are of better quality because you're able to simulate those scenarios up front and test them and develop them and give those kind of demos to your customers. You will end up saving a lot of money, and you might even end up making more money on your revenue side. Okay, so we saw a few slides back like how you would do things with the mocking, and there we showed that if you have an API design, then you have to do pretty much development testing before it is available to your users. But here is a different approach that we are proposing. You should take your API design, that is an OpenAPI specification, and just use ServiceV to create these realistic simulations before writing a single piece of code. Just simulate your APIs on ServiceV. And once you have done that, you have realistic APIs, which are almost like your real APIs. And then you can use them to give it to your testers for testing, for your developers of your applications to incorporate it in their web applications or mobile phone applications if they're using it. You can build very solid prototypes on top of these APIs. You can build these prototypes and do a demo of these prototypes to your customers. You can show the work that you have done, your API specification, to your managers. And you can also give them to your customers to use them. So if you're an API designer or a developer and your customers want to see the design and they want to know if that works for them, you can give them an actual API instead of an API design, which might not make sense to them. So give them an actual API instead of your design, and give them the simulation of the actual API through ServiceV Pro, and they can use it and they can give you feedback, right? And this is very important because this feedback you can then incorporate and change your design appropriately, and then give them another version quickly. So instead of going through that development loop, if you don't use service virtualization, you have to go and develop these APIs, feedback comes back to you, and then you again change your code, and then you again go and give that updated APIs to your customers. But with ServiceV Pro, with a few clicks, you can incorporate your updated APIs into your mocks and advanced services, virtual services, and you can send it back again for another round of feedback to your customers. So what's the benefit here? The benefit is that you are improving your design very much upfront, right? You're not waiting till the end of your SDLC to give your customers and users something that works. You are actually getting feedback upfront. You just design an API, and you're able to emulate them in ServiceV Pro, and you get immediate feedback, right? So that improves your design upfront, and you do not get into the problem of finding those design issues in the later stages of your SDLC, where fixing those issues would be a real problem because you have to again go back and do the design, code, test, and everything. So you save a lot of time and hassle, and from upfront, you're delivering a really good and robust design. So that's the value the ServiceV Pro or a service virtualization solution adds, if in case you're using an OpenAPI specification or a definition. Right, so I think it's time for us to now look at the product, the ServiceV Pro. We have talked a lot about it. So Mike is going to show you what ServiceV Pro looks like. He's going to show you how he can incorporate an OpenAPI specification, bring it in, create advanced mocks, advanced virtual services from it, and then he will show you how he can dynamically modify them using data sources and how you can quickly change them and then provide those advanced mocks to somebody who can consume them.
All right, thanks very much again, Hirsch. So the first thing we need to do is take this design that we already have and then bring it into Ready API to be used by ServiceV. What we can do in that case is call an API within Swagger Hub here. So I'm just going to change this to swagger.json. to access that API, get this nice JSON format of my definition here. And then from here, I can go into Ready API. And what I'm going to be doing is creating a new project. Before I do, though, I'm just going to take a quick second to talk about Ready API itself. So Ready API is our API quality testing tool. Within the platform itself, we've got a number of different tools here. We've got SOAP UI for functional testing, making sure our applications work as correctly. We're able to spin up these really quick and easy user scenarios, validate responses, data drive this entire process, have this advanced reporting feature and automation. We can take these SOAP UI tests and bring them into secure. So now that we know our application works as intended, we can see how it stands up to malicious kinds of attacks. We can also take our SOAP UI scripts and bring them into Load UI to see how they perform at scale. We can also do some advanced metrics and again, pipe that into an automation or CI/CD pipeline as part of our testing process or build process as well. But today we're going to be focusing on ServiceV. And like Hirsch mentioned, we're able to create these advanced sort of mocks, be able to create and dispatch different responses, add logic. We're able to modify the behavior of these virtual services so they're more realistic to a production environment. We're able to call these data sources within the responses, but we're also able to refactor and iterate on the designs, whether it's coming from the Swagger open source or something like Swagger Hub. We're able to update these designs within Ready API with just a re-import. And we're also able to collaborate on these designs, as we'll see with VirtServer as well. So the first thing I'm going to be doing is, of course, importing this project here via this descriptor file, bring it in from this OpenAPI definition. All right, so we took that link that we saw, calling that JSON, and I'm just going to call this SB library. There we go. So once I save this, Ready API is going to be able to read these different, excuse me, that's a sample project here. Read these different resources, these different methods that we've created. We're able to see the request and the individual parameters that we fleshed out within this design itself. So that's all imported and parsed out for you within the tool. Now that we have this, we want to be able to create that virtualized service in ServiceV. So what we can do is we can take this interface here, right-click, generate Vert. Right, so that will be able to recognize all the different methods for our resources, but we're also able to customize what specific port we want to be hosting on it as well. And then when we hit OK, it brings us into ServiceV, already has the context with the different resources, the different methods. And in addition to that, we also have these sample responses as well that was again defined within our specification. So we have our 200 OK with our response here. And then for response 2, we also have our 404 error. Right? So from here, we can see how we can quickly get set up, importing our design, be able to transfer that over into ServiceV and see how Ready API, it's powerful enough to be able to read that design, but also be able to spin up this framework API based on that specification.
I just wanted to add a comment here. I think Mike started creating this 1 minute back with that specification, and within less than a minute or so, he was able to create these API responses, and it's just pretty much ready to go for any purposes. Yeah. So that's the value that a tool like ServiceV brings to you. You are able to take an existing specification or definition for an API, and within a few seconds or within a minute, you are able to create these mocks. and then you are able to take next steps of like making them even more advanced going forward.
Exactly.
And I also wanted to say that if you have any questions, please feel free to ask those questions in the chat box or the question box. We'll be happy to answer those questions for you guys. Thank you very much.
Yeah, 100%. Thanks, Harsh. So yeah, absolutely. We could definitely stand this up. We already have the endpoint here, so if we wanted to, we could go to localhost 8065. Copy this resource path. And then get back a sample response. The way it stands now is that if I reload this, make this request again, we're getting back our 404 status, and then going back to our original response here. This is because of the way that we're dispatching these different responses within ServiceV right now. So what we want to do next is be able to customize this dispatch style, create some more sample responses here, and then be able to flesh out how we can create that context within ServiceV and go from this static design to a more robust and flexible virtual service. All right, so what I'm going to do for here is take this this method here, book/ID. I'm going to rename this. ID is 105. I'm going to rename this to our 404 so we can remember what these responses do. And then I'm going to create a couple more responses, flesh this out a little bit more. This is going to be my 106. And my 107 response. There we go. So we're big fans of Game of Thrones here, so I'm just going to rename these. Change the ID. Awesome. So we have our 3 responses and our 404 error. All right. So we want to be able to create some sort of conditional logic on how we can actually dispatch this. In this case, it's going to be a path parameter. So I'm going to choose that parameter dispatch style. We also have other ways we can dispatch these responses. So in addition to that sequence that we saw earlier with the browser, we're also able to dispatch this randomly. We're able to take a look at certain queries and match them. XPath, so especially for those SOAP responses within the XPath, we're able to search for a specific value and then dispatch a response accordingly. And we can also script this out. This is a little bit more complex if you want some very specific properties that you want to be dispatching your responses through. Something like those cookies that Hirsch remained earlier. You want to keep those, maintain those, and be able to get your responses back accordingly. All right, but in this case, we're going to be using the parameter option. My default response is going to be that 404. This is just a good catch-all for any garbage input, no input within the path. So we want to be able to catch all those errors there. And then for our responses, we're going to create these if-then statements, basically to say if this path parameter ID is equal to 105, we're going to get back a 105 response. All right, and then the same for 6 and 7. One more. All right, so now that we've made that, I'm going to restart our virtual service, and then I'm going to say I want book 105. 106, 107, and I'll throw in some garbage here to get that error response. All right. So we're able to create these, this conditional logic, be able to create context within our requests, get back the appropriate responses, and this is incredibly powerful. We're able to do this within a matter of minutes, no scripting involved. Barely touch the keyboard at all, and we're able to create some responses and some real context that might act like the final API within production. All right. So now that we've done this, this is sort of an initial design, but as your architects, the people who are actually designing these APIs make changes, you want to be able to show off those changes accordingly within the design itself. So what I'm going to do is I'm going to stop this service, go back to Swagger Hub, and make a change to that design. All right. So as we can see from these methods here, we're able to get some authors, we're able to update some authors now that we've posted them. But what I'm going to be doing is adding a delete method so we can remove those authors, re-import the design, and then see how we can refactor this design within Ready API. All right, so one more indent. All right, perfect. Save this. So now that that change is made, and we've seen that delete method was added, let's go back to Ready API. And go back to this projects tab here. And then the way we would go about refactoring this is we're going to update this definition. This gives us some options to delete resources that were created, some of those more custom ones. But it also allows us to add new methods to our virtual service. So that's exactly what we want to do. We want to bring that delete method in. And of course, this is going to be a Swagger. This definition URL hasn't changed, so I'm not going to touch that at all. So we hit OK. We're going to see that that delete method was added to our user's resource. And it's also added to our virtual service. So it's a really quick way of importing and updating these virtual services, a very iterative process within the design, without having to recode out these new methods, these different responses, how we're getting back. You update the definition, save it, and then refactor it and bring it into Ready API. All right, so now that we've talked about sort of the customization of this virtual service, how we can dispatch these different responses in various ways, including parameters, how we can iterate and continuously work on these designs and keep them up to date within the tool. Let's talk a little bit about more what ServiceV can do. So we have this way to change behaviors. We can change something like this latency here, which we can add maybe a second of latency here. So this would be able to mimic a design or an API that would be in production. So we can change the behavior like that. We can take a look at this transaction log so we can see the transactions that we've actually made against this virtual service, including the requests and the response. We can add authorization to this as well. So if the API is going to be placed under some sort of OAuth 2.0 security until NTLM or some sort of custom header, security header, we're able to create those as well. All right. And we mentioned this earlier. Hirsch said we're able to bring in some backend information, Excel files, database connections. We can create some random data that we're able to bring into our responses as well. And that's what we're going to be doing now with this data sources option here. So for this scenario here, I think it would be a good idea to add another response, be able to create some travel guides. And so what we're going to be doing is generating these randomly here. So I'm going to choose that data generator option here so we can create some random IDs, create some random first names, last names, and locations for these travel guides here. So I'm going to create an ID. It's going to be an integer between 100 and 999. We're going to create a title. It's going to be a state. There it is. We're also going to create a first name and a last name for our author as well. All right. So now that we've created our data source, let's bring it in to one of our responses here. I'm going to add a new response for this, call it random, and then just copy over this response here as well. All right, so instead of this static sort of response here, I'm going to create, bring in that ID. First, we're going to connect our data source here to that data source 1 that we've created. And with a right click, I'm able to use this get data option here and then bring in these random titles, random IDs, and first name, last name combinations that we've created here. So this is going to be our ID. We'll call this a nice place to visit. All right. So now that we've created this, we're going to create sort of a dispatch option here. So if, let's say, our query parameter is, say, random equals true, we're going to get back that random response here. All right, and if we stand this up, we'll be able to hit this from our browser. We can see that we've gotten back our title, North Carolina, a nice place to visit. It's got a random first name and last name and a random ID here. So let's do this a couple more times, drive home the point. All right, so this isn't an especially practical design, but it's a nice way to illustrate how we can bring in data from different sources here, whether it's randomly generated like our example here, or whether it's coming in from an Excel file, a database connection, a CSV, what have you. We're able to bring those into our responses, be able to create our rules, and be able to show that off when we actually make this call to the API. All right, so I want everyone to keep in mind that ServiceV is a local tool. We're able to very powerfully design this API, bring in the Swagger definition, spin this up, and be able to make requests against it. But this is, as it stands right now, all in a local environment. If we wanted to collaborate on these designs, Hirsch wanted to make some calls against this service that I've created, he wouldn't be able to do that. Thankfully, though, SmartBear has created another tool to work hand in hand with this service here. The idea behind VirtServer is that we're able to create and host these or host these services that we've created within ServiceV, push them to a remote location, and then be able to collaborate on these designs here. So let me.
And these remote locations could be any server that includes something that is sitting right next to you on your desk, or it could be AWS instance for that matter?
That's
Okay.
exactly right. Yeah, it could be your neighbor's machine. It could be a server you have locally, or some sort of cloud service. We're able to push these designs to that Vert server. We're able to run them and be able to make these requests via this URL and whatever port that you configure onto the Vert server, and then we're able to bring these down, change them, update them, and be able to push them back up there.
So maybe you can take this question while you're configuring the Vert server.
Sure.
And so Jordy had a question like, so is it possible for this definition to be used directly by Vert server without using the UI, the front end? Maybe through command line or directly in the backend?
That's a good question. I have to follow up a little bit more. Do you have any sort of insight into that?
No, I don't. But yeah, we can definitely send some documentation information around to the group.
Absolutely.
Around that question, Jordy. So we'll get back to you on that.
Perfect. All right. Well, let's see. It's possible. This. Something's happening.
I think you've made the point that we can share those services on the cloud. So maybe we could spend some time once you've demonstrated the Vert server on recording these services. Quickly show how you can record using a recorder, which is I think pretty awesome.
Yeah, absolutely. So in addition to creating these services from scratch, whether it's from a definition file or whether it's completely manually, you flesh out the resource path, you flesh out the responses all by hand. We're also able to record transactions from live services and bring them in, localize them. And the reason you would want to do this is for APIs as a part of your testing cycle, these different use cases that you would reach out to a third-party API. APIs that are a little less reliable, sometimes they're up, sometimes they're down, but you want to be able to test consistently against them. But also APIs that have some sort of transaction limit or will eventually charge you for a certain number of transactions that you make against them. So what I'm going to be showing off is creating a new service here, and we're going to do this from scratch. We're going to reach out to Google Maps. This is especially a temperamental API that I found recently, but one that will also, eventually cut me off. There's a limit to the number of transactions you can make against it per day. So what I'm going to be doing is route to maps.googleapis.com. Right? Make sure that we choose the route and record non-verted requests. We're going to use our resource path. I believe it's Maps API. And then using this method here, or this resource, we're going to reach out. We're going to get back some geo information about a couple of places, and we're going to record these responses here. So I'm going to set this up and then reach out to it using my browser here. So instead of the live API, I'm I'm going to reach out to localhost 8080 where I set this up. All right, so we're going to make this request to Boston. Route all record responses 8080. Okay, so it seems like we're routing successfully to this. We're using this localhost 8080. We're making this call. We even got back this new response here. So I'm just gonna take an extra second here. Not all. Spin this up again. There we go. So we're able to get back and record a transaction for Austin, Texas. We're going to do the same for Boston, New York, and we'll throw in some garbage there as well. All right, perfect. All right, so yeah, it seems like we've exceeded our quota for the day. This is exactly why we want to record these transactions and be able to get a more consistent sort of a version of the API that we need as well. So let's try this one more time. All right. So once we hit shut off routing, we can play around with these responses here. So this is the Austin response. We're able to go into this response, be able to change it, add nodes, what have you. We also have this catch-all here, this sort of garbage response that isn't, so it's our error response that we can say, this is the catch-all error that we want to throw when there's this garbage parameter, no parameter. And we're also able to create, pardon me, there we go. We're also able to record the parameters and configure that dispatch that we've designed. So not only are we able to record the transactions, we're also able to record how we're bringing them in via that parameter. All right. So yeah, that's another one of the larger and main use cases for using ServiceV. Not only are we able to design these APIs by hand or from some sort of definition file, but we're also able to record live transactions, be able to bring them under our local use, so we can change them as we needed, and have a more consistent, reliable version of the API as opposed to reaching out to that third-party service over and over again.
So there's a question by Robert, and he's asking, we showed the virtual service being created from an OpenAPI definition. Yep. Can we create these virtual services from a WSDL?
We are, absolutely. Do you have an example? Give me one moment.
I'm assuming the process is pretty similar to what we did for.
Yeah, it's very similar.
Take the WSDL instead of the OpenAPI definition, and then you import it, and you have mocks ready to use.
Exactly right.
Okay.
Yep.
That's good. All right, I think we should go back to the slides at this point.
Sure, yeah.
Running pretty close to the end time of the webinar, and just have one more slide to go through, which is basically the conclusion slide.
Okay.
Yeah, so in summary, I hope today's webinar you were able to get a glimpse of the OpenAPI specification and how it can be useful for your API work with your APIs. If you have been doing mocking, I hope we were able to convey the differences between what you have been doing so far with mocking and what value service virtualization provides to you, the incremental value. And you were able to learn a little bit about how ServiceV Pro can be a very useful tool for you in your design and development of APIs. And it helps you in taking your API design and providing realistic API emulations created from those design and providing it to your end users and consumers and getting early feedback on your design so that you're able to iterate on the design and make it even better before you write even the single piece of code. So, well, ServiceV Pro is a very easy to use tool, and it doesn't require any experience with coding. It enables you to create dynamic responses. And of course, as we saw, it enables you to share these awesome services that you have created with your team, whether they are in next door or they are across the ocean in some other country through sharing. So with that, I would pass the webinar over to PJ for any concluding remarks you may have.
Great. Thank you, Harsh. And thank you, Mike. Thanks both of you for taking the time today. So before we wrap up, I just want to remind everyone that both of these tools that we had a chance to show today, Swagger Hub and ServiceV, are both available online for a free trial. So if you want to go in there and check them out, play around with the tools yourself, you're more than welcome to do that. You can do that at smartbear.com. So definitely check that out. And additionally, we'll be sending out the recording of this session so you can kind of go back and get a glimpse at what we just talked about and maybe share it with your teammates if you think it's something that other people might find useful. So stay tuned for that in the next 48 hours or so. But that about wraps up today's session. So I just want to thank everyone once again. We appreciate you taking an hour out of your day to listen in with us here at SmartBear, and enjoy the rest of your day. Take care.
Thanks very much, everyone.
Thank you, everybody.